Hello again, folks. I really hope that this solving one-step equations, solving equations 1 lesson went well, and that homework was nice and easy as well. Solutions are posted. Please double check those. And today we're going to do a lot more left side, right side checks, but you should ensure that you're doing left side, right side checks the entire way through your homework from yesterday. So today we're going to talk about solving two-step equations. Recall that to solve an equation is to find the value that makes both sides the same or equal. Yesterday we did view a video on solving one-step equations using the opposite operation. And those keys are going to come into play again today. Recall the opposite operation of multiplication is division and reverse. As well, the opposite operation of addition is subtraction, and again in reverse. Today we will look at how to solve two-step equations, and you could extend this concept to solving 3, 4, and even 1,000-step equations. Let's take a look at our first point. We can save time and steps by using the proper order to solve two-step equations. Here I have a two-step equation. It's going to take more than just one operation to undo around the variable. We've got different names for these terms though. The term that contains 4x and the constant have different names that we'll call them by. A term that does not contain the variable you're looking for, in our case our constant, is called a separate value. That's our minus 2. A term that does contain the variable you're solving for has a coefficient. The coefficient here, 4, is called an attached value. When we're solving two-step equations, it's important to note that first we undo the separate value, then we undo the attached value. Let's take a look at example number 1. Example 1. Solve 2x minus 6 is equal to 2. We have a separate value of minus 6, so first we'll undo it. We'll add 6 to both sides of the equation. This will leave me with 2x is equal to 8. The minus 6 and minus 6 cancels, leaving me with 2x on the left, and the 2 and the 6 combine or collect to leave me with 8. Next is my second step. I have to get rid of my attached value of 2. Yesterday we learned to eliminate a value attached by multiplication, we divide. We'll use that same idea today. And what we do to one side, we must do to the other. So 2x divided by 2 is equal to 8 divided by 2. When we simplify, we find our answer. X is equal to 4. I mentioned we're going to do some more left side, right side checks. Today we're going to use a little t-chart to help us out. On the left side of the t-chart, we'll write out the entire left side of our equation, 2x minus 6. On the next line, we'll substitute our solution. We said x was equal to 4, so we'll sub that in. We'll simplify a little bit. 2 times 4 is 8. So we're now left with 8 minus 6. And 8 minus 6 is 2. When we go back and check the right side of the equation, we find that it was equal to 2. Since the left side is equal to the right side, x equals 4 is a solution. I think we're ready for example 2. Example 2 looks a little bit uglier. Nobody likes fractions and nobody likes subtraction and division. It seems strange. So here we have x divided by 4 minus 3 is equal to 9. To solve this, we'll use the same steps. First, we'll eliminate the separate value by adding 3 to both sides. When we do that, we'll be left with just the x divided by 4 on the left and 9 plus 3, or 12, on the right. Now we have a value that's attached. The 4 is attached by division. To get rid of division, we multiply. We'll multiply both sides by 4. That way they'll cancel out on the left, leaving us with just x, and we'll have 48 remaining on the right. X equals 48 is our solution. Let's double check that in a left side, right side. So we'll set up our chart again. The left side of the equation was x over 4 minus 3. When we substitute in our solution, that leaves us with 48 divided by 4 minus 3. Well, 48 divided by 4 is 12, and if we subtract 3 from 12, we end up with 9. Conveniently enough, that equaled our right side, which means that since our left side equals our right side, x equals 48 is the solution of this particular equation. I think we're ready for example 3. Just a note about left side, right side checks. You've probably noticed now that it would be absolutely entirely possible to prove that you had 100% on your homework or 100% on a test if you simply do the left side, right side checks. Sometimes they will be mandatory, and I'll tell you explicitly, do a left side, right side check, or do a formal check. Other times it'll be entirely optional, but I would suggest it. Example 3. Solve 6x plus 2 is equal to 32. Here I have a separate value of plus 2. I'll subtract 2 from the left side, and in doing so I force myself to subtract 2 from the right side as well. This will get rid of my separate value. On the left side I'll be left with just 6x, and on the right side I'll be left with 30. Now I have 6x is equal to 30. I have an attached value of 6. To eliminate my attached value, I'll divide both sides by 6. Dividing the left side by 6 will cancel out and leave me with x. Dividing the right side by 6 will leave me with 30 divided by 6, or 5 on the right side. I come down to my final solution of x equals 5. Once again, I'm going to do a formal left side, right side check. I'll set up my little chart, and the left side of the equation was 6x plus 2. I substitute in my value from my solution. X equals 5 goes into where the x is. So I have 6 times 5 plus 2. I'll simplify a bit. 6 times 5 is 30. Adding 2 to 30 leaves me with 32. Remember to follow your order of operations properly, or you can get hung up in your checks. Well, the left side equaled 32, and the right side of the equation equaled 32 as well. So we know that x equals 5 is our solution. You should now be prepared to do your homework that is listed as 1-7 homework. There's 2 pages of problems. Please ensure that you do these on a separate piece of paper and include all proper left side, right side checks. Thank you, and have a great day.